right. So did you want to go into the extension problems, or did you just want to jump into straight into the group quiz?
We can just see if there's any extension problems that we want to go over. So.
Okay. Let me just go real fast. Okay. We're discussing some different identities, so on so forth. Okay. Alright, extension problems. The application of the identities was to be able to use them to solve for a specific value. Begin by going through the following problem that has been outlined for you, and then you'll be asked to do a similar problem. So question, find cosine a over 2 given sine of alpha equals 3 over 5. And pi over 2 is less than a, which is less than pi. So what is the question asking you to find? Well, if it's anything like the problems you're working on before, where like alpha and beta was the angles of a triangle, and then A, B, and C were the sides. So I think it's a side we're looking for, like a side length.
Yeah, I would agree with that.
Okay. Begin by writing the identity for cosine A over 2. This is where it gets fussy for me.
Yeah. So cosine x over 2 is plus or minus the square root of 1 plus cosine x over 2.
Okay.
So so if cosine a over 2 equals the square root plus cosine a over 2, is that right? So in order to find cosine a over 2, you still need to know what cosine of a is, because it only gives you sine.
Like alpha, or?
Yeah, I keep saying a, just because that's what I say in my head. I know it's supposed to be alpha.
That's fine, so.
Yeah. Okay. So.
Well, try and help you find the missing piece. I would assume yes.
Yeah, so it probably is just like Pythagorean theorem. You can just do so it's supposed to be in the second quadrant.
Yes. We're trying on the correct quadrant, find the third side, so. Second quadrant, right triangle. Let's see. Square root of 1 plus cosine alpha over 2. Now, in order to find the cosine of alpha, we basically take sine of alpha and we square it and then subtract it from 1, right?
I was kind of thinking about just using, so you know how like sine is opposite over hypotenuse?
Uh-huh.
I was thinking you would just find the last side by using that. And so you would just do 5 squared minus 3 squared, which gives you 4. So then cosine would just be 4 over 5.
Wait, so 5 squared minus 3 squared, wouldn't that be 6?
No,
Because you have 25 minus 9. Wait.
it gives you 16.
Gives you 16. Oh, then you square that, and you get 4. Okay, never mind. Go ahead.
Yeah. So then you would just plug that in for the identity. So you would end up with what's that? 9/5 over 2, which is 9 divided by 10. Or I mean, I gotta write this down. I can't do it in my head. So it gives you 9/5 over 2 times 1/2, which gives you 9/10. Yeah. So the square root of 9 over the square root of 10, which would give you 3 over 10. Well, hold on, let me see something. 1 minus 4.
So, are we trying to find the angles too, or just the sides?
Hmm?
Oh, I was saying, are we trying to find the angles too, or are we just trying to find sides right now?
Yeah, so we're just trying to find cosine of A divided by 2. And the answer that they have on there, I think they did the wrong one, because that's the answer for sine of A divided by 2.
Okay, I see.
So, because when you do 1 minus 4/5, then you get 1/5, and then when you times that by 1/2, then you get 1/10. Maybe I'm doing something weird. I don't know. But
Okay.
later is 2, and all of that is square rooted. All right. So 1 plus 4/5
Gives you 9/5.
gives you 9/5. And then that divided by 2 should give you 9/10. So then you have the square root of 9 divided by 10, which simplifies to the square root of 9 over the square root of 10.
So that would give you, let's see, 3 over the square root of 10. So,
yeah. So, I mean, I don't know if I'm doing something wrong or if the key is not right.
let's see. Because, let's see, you found that 4 was the third side. Hold on, I'm trying to think. Cosine of A over 2. A over 2.
So
So
I'm
would A,
looking at the key, and
well,
it
say,
says,
So would A be equal to 3 then, or am I thinking of something else?
So we're not really trying to find, or so we know what sine of A is, and so we know sine is the opposite over the hypotenuse. So the opposite is 3, and the hypotenuse is 5.
So
And we have to find that.
no, sine would be the adjacent over the hypotenuse, which would be -4/5.
Yeah, I just didn't put the -4. So it would actually turn 1 plus cosine A into 1 minus 4/5.
Which gives you 1/5, and then, oh, that's why how they get it then.
Yeah.
Because you get 2 times 5
1
is
over
with the 1.
5, yeah.
And then you square root, and then you get, yep, that's how you get 1 over the square root of 10, okay. Okay. I think I understood that, so yay.
Awesome.
Here we go. Sine of alpha plus beta. Given that sine of alpha is -3/5, it is in the fourth quadrant, and cosine of beta is -1/3 in the third quadrant.
Okay. So the sine of alpha plus beta is the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So we know that the sine of alpha is -3/5 and the cosine of beta is -1/3. Is in the third. Okay. So also, that would be, it's in the fourth quadrant. That's 4/5.
Anyway, sorry about that. I had to run off and check on my cousin's real fast, so.
Oh, that's fine.
Wrong one. Okay. Square. I think I'm getting this wrong. Oh, no, never mind. Never mind, we're good. 4/5. Square root of 8. think I understand what's going on here. I just trying to figure out how to get the last result. Because I can figure out that we have 8 times the square root of 2 over 15. Like, I look at the key and it's supposed to be 3 minus 8 times the square root of 2 over 15.
Yeah.
Well, that's the answer according to the key. And I'm trying to figure out how they got there because I got the 8 times the square root of 2, but I'm trying to figure out where the 3 came up in the numerator. So. It's confusing.
So for okay. I always evaluate it much more than I need to. So for the sine of beta, did you get negative square root of 8? And for the cosine, get 4 over 5? The cosine of beta.
So yeah, I got the square root of 8 over 3, and then 4 over 5, yeah.
I just got the square root of 8.
Just the square root of 8?
Yeah. Because
let me look back. Let's see. Let me look back at it real fast to see if I missed something.
so if cosine of beta is 1/3, that means the adjacent is 1 and the hypotenuse is 3. So in order to find the opposite, you would just do 3 squared minus 1 squared, which is 9 minus 1, which is 8. And that.
Oh, okay. I see where you're going with that. So that would explain where the 3 came from then. Times that.
So then when you do all the multiplication to make the denominators the same, you end up with 3 minus 8 squared root of 2 over 15.
Okay.
Apparently. Which, that even still doesn't make sense to me. I still don't know how they got that answer. Now that I'm like working it out.
I think it's the correct answer because I got the key at the same time, and I don't know what it looks like is that once you flipped over the cosine of beta with 1/3, you flip that over. So that's how I get 3 in the numerator. 8 times the square root of 2. So you get that from the sine of alpha when you square it, and then you subtract it from 1, which gives you 16 over 25, and then you square root that, you get 4 over 5. And so let's see. Because the reason why I got A was I did cosine, where I did 1 over 9 minus 1, and that's how you get the 8. So where's the square root to come from the question, though?
The thing is, so the identity is that the sine of alpha is times the cosine of beta, which I got to be 3/15, plus the cosine of alpha times the sine of beta, which I got to be 4 square root of 8 over 5. Now, in order to properly subtract these, you would have to multiply 4 to the square root of 8 over 5 by 3, so it'll match 3 over 15. But it just looks like to me in the answer key that they didn't do that. Because I mean, if you don't do that, you can just simplify the square root of 8, and you end up getting 2 times the square root of 4. So then you would, or 8 times the square root of 2. So then you would end up with 3 minus 8 square root of 2.
Okay.
They're both not over 15. I really wish they would kept the key better. It's not the first time that the key has been weird. I don't know. Maybe that's a problem for us to ask Sister Hess about.
Probably. I don't know. It's like I'm trying to think it through, but it's giving me issues. So
All right. Well, I'll email her. I hope I- Okay. All right. Let's just go ahead and move on. If I
yep,
dwell
sure.
on a question too long, I crazy.
No, it's okay. I'll go over that a little more later. So we'll go on the next one.
Okay.
As a team, verify the following identity. Remember that for the tan of pi over 2, there are 3 different options for the identity. So tan pi over 2 plus cotangent pi over 2 equals 2 cosecant. Oh, I think I know this one. So tan is sine over cosine, and cotangent is cosine over sine. So what? Okay, I see. So basically this simplifies it to 2 over sine of x.
Mhm. So
Well, I'm trying to go through it myself, but basically how it simplifies out is that tan is basically, let's see, according to the trig sheet, it was sine over cosine, and then cotangent was cosine over sine, and let's see, so was it cosecant? Cosecant, 2 cosecant was basically 1 over sine.
yeah, it's just how they got 2, like how 1 minus cosine plus 1 plus cosine equals 2.
Well, because 1 is still positive in those cases, like see, because when it adds, it's still adding 1 to 1, and then negative cosine to positive cosine. That's how cosine on the top cancels out. At least that's how I understand it. I could be wrong.
Oh yeah, that makes sense. Awesome. Awesome, awesome, awesome. Okay. So it looks like this last one is kind of like done in parts, and it's like a guided verification thing.
Okay. Last step, verification. Number 5?
Yeah.
Number 5, number 6.
It starts at number 5, but the number
Instructions.
6 works into it.
Okay. Be sure that each team member is confident in each step. So how can we rewrite so that we can use identity?
You could take so like on number 6, looking at the bottom one.
Yeah, it's like it takes a 2x plus x, and it kind of like simplifies it further, it looks like.
Yeah, and on the other side, you could take out the 3,
Mm-hmm.
or like a negative. Oh, I'm trying to think. You don't take that
Mm.
out. I'm trying to see how it's done. Man, like like the extension problems that we go through, and even the group quizzes, I feel like the group quizzes are the hardest out of like all of
Yeah.
the testing that we do. Group quizzes are always really hard. They feel hard, but we actually get like 90s on them sometimes, which is surprising to me.
I think as long as we're participating and trying to work through them, I guess we get credit, so at least most credit.
And Sister Hess is really nice about a lot of the exam stuff, like redoing
Yeah.
questions and and things like that. Man, even looking at the answer key for this last part, I am no idea what's going on.
No, not so much. I'm trying to figure out the processes.
Okay.
Because I think, well, maybe. I don't know. Because it almost looks like these were number 6 that we're trying to FOIL it out. And then, like, times 2 sine of 2x plus x across. That way it, like, you know, comes across.
Yeah. Looking at the answer key, I just don't see why sine of 2x plus x turns into sine of 2x times the cosine x of x plus the sine of x plus 2 cosine 2. I think that's some identity thing. See if I can find it. Okay. So the sine of 2x is equal to 2 sine x times cosine x, which makes sense, but that's not really exactly what the answer key says. Plus sine cosine. Maybe it's the like sum and difference. So like the sine of 2x plus x. So that 2x would equal alpha and x would equal beta. So then you would just rewrite it as the sine of 2x times the cosine of x plus the sine of x plus cosine 2. Okay, that makes sense. So in number 6, they're rewriting 2x plus x using the sum identity of sine A plus B.
Identity of sine A plus B.
Yeah. In which terms that alpha equals 2x and beta equals x. They just kind of switched the second half so that it was sine of x and cosine of 2x.
Okay.
All right. So we got that first part.
All right. Okay, I see now. Okay, well, hopefully after a little bit of confusion, we'll be able to do the quiz without too much hassle.
Yeah.
Okay. Okay, looks simple enough, at least for number 1. Looks like we have to simplify a couple expressions first, so A is equal to sine of x over 1 minus cosine of x plus 1 minus cosine of x over sine of x. So that kind of looks similar to what we were working on just now with the first one.
So let's pull up what Sienna had. Okay. So either I can write this down or we can, well, what Sienna said is if we agree with her answers, honestly, we could just turn the sheets that she gave to us in.
Well, we could, but didn't she prefer, excuse me, didn't Miss Sister Hedge prefer if we used the group quiz format, like the one you scanned on, or no?
I think one time I was just looking through the grades, and I think it might have been Tim submitted. I think he had just like typed it out, but I don't know.
Oh, right.
I think as long as she knows like what the question is and what the answer is, then
Okay.
it's okay. So if we do agree on like all of her work that she does and agree with the answers, then go ahead and turn it in. And if she does, and if Nathan or her have a problem with it, then we can fix that easily.
Okay.
So.
Yeah, I was looking at our question right now, and I'm trying to see here. And she starts off good, except I'm trying to figure out how she gets this problem here. So I'm just trying to work it out in my head here. Letters the sign. It looks like she ties the whole thing, at least most of the whole thing, by sign again, or at least.
Yeah. This is just like the one in the extension.
That's what I'm saying. I think I understand now. She like flips it, then times it itself. So.
Yeah. She went into a lot greater detail than I would have gone in. But she did prove it. So.
Yeah. So that cancels out. That simplifies. So 2 over sine of x, which equals 2 over cosecant of x. I mean, it makes sense for the most part. I was just trying to figure out how she got the first tidbit in the top right corner, but.
So what she did is, in order to make the denominators equal each other, she timed the first fraction by sine and the second fraction by 1 minus cosine, so that they would both equal 1 minus cosine.
Okay, I see now. Okay, now I get it.
And then since they both equal the same thing, she could just put the whole numerator together under the same denominator.
Under the numerator, yeah, and then simplify from that point. Because everything else seems to look okay from that point on. I was just trying to figure out how she got to that point, but that makes sense now.
Yeah.
Because usually when I write it out, I put like a times by this, that way it gets to that stage. So.
Yeah. Okay.
It works. Okay, let's see. Tan of alpha cosecant squared alpha minus 1. Okay.
So she is the identity of 1 plus cotangent squared x equals cosecant squared. So she just substituted.
Mm-hmm. And tan is sine over cosine, so then times the cosine has squared, that gives you the square and cancels out the left degree. Let's use cosine over sine, let's use cotangent of alpha. Okay.
Yeah, I would agree with that. With what she did.
Okay, cotangent sine plus cosine squared secant. Cotangent is cosine over sine, and secant is 1 over cosine. That cancels those out, which gives you cosine minus cosine, which equals 0. Then 1 minus sine squared over 1 minus cosecant of negative x. So times it by negative 1, so that gives you those. Okay, I see. 1 minus sine squared of x. Cosecant. Here, hold on, I'm gonna get the sheet.
It looks like she wrote down her answer wrong. Like the one she has in a box.
Yeah, it looks like the exact same thing as the beginning, so I'm trying to figure out, well, at least kind of similar to the beginning. Hold on, let me double check to make sure I'm getting this right. Hmm. So it almost looks like she starts in like the first line and then she like starts over.
Yeah.
Or at least tries a different approach. 1 minus sine squared of x, cosecant of x plus 1. Hmm. So I wonder if she wrote down like only half the steps, because I usually try to write out every step that way in case I get it wrong. I try to at least go back and see what happened, like where I got it wrong, but I don't know. I'm trying to figure out where it jumps.
Yeah. So okay. I think I see what she did. So what she kind of did is like kind of factored out 1 plus sine of x out of 1 minus sine x, or sine squared x over 1 minus cosine of negative x.
Okay. Okay, factoring. Yeah, I can see that now. So she factored. Let's see. Hmm. That doesn't quite explain how it like equals itself at the end, though. That's what I'm trying to figure out. Is that what the question's asking, or?
No, that's something different. But she has the equals. Because it's supposed to just be 1, well, I'm going to say 1 minus sine because it's 1 plus sine of negative x, which is the same as 1 minus sine equals cosecant. Okay. Let's see here. So I just don't know how to get cosecant by itself on the bottom. Oh. So if you do, I think if you times, so if you times cosecant by 1, you get cosecant. Cosecant times sine would just give you sine over sine, which is 1. And that would be like a plus 1.
Okay. Okay.
But then that's not what we're looking for. We need, oh, actually that does work. Yeah. Okay, so I kind of see the mistake that she made, in a sense. Because kind of what she did was like she took whatever she took 1 minus sine x over cosine x and then times it by something to get 1 minus sine squared x over cosecant x plus 1, which isn't really what you're supposed to do. You're supposed to prove that they equal each other.
Yeah, that's what I was wondering, because it sounds like she managed to make them equal each other, but she didn't quite explain how she got there, so.
Well, it looks like I mean, I don't see anywhere on here what the question is asking. I mean, I don't see how 1
Well,
minus sine squared x over 1 minus cosecant equals 1 plus sine negative x over cosine.
well, she wrote out the original equation from the math sheet, because that's letter B on 2, and 2 says using the identities you have learned and the different strategies, verify the following identities. So
Yeah,
I
they're
guess
supposed to equal each other.
yeah, I guess she technically did that. It's just that she kind of made an abrupt finish. It looked like.
I mean, the identity.
Oh, I guess are we satisfied with our answer then?
Hmm?
Oh, I was just saying, are we satisfied with the answer, or do you feel like we need to kind of add to it to explain the step further back to verify?
What I'm trying to say is that I don't agree with what she put. Because, well, I mean, all she really did was she didn't really use any like kind of identities to change like the left side to look like the right. I mean, she just multiplied it by an equation. She didn't really use, like I said, use an identity to make one side equal the other. You know what I mean?
Yeah, I know what you mean.
I think she kind of misunderstood the question. And I'm trying to figure out how to do it myself. Um,
I think she tried going back too early. I think that's the problem. Or, I don't know. Sorry, I'm just kind of staring at what she did here, and I'm thinking, because in the middle of the second line, it looked like she had foiled it out, and then she tried foiling it back in already. So I'm almost wondering if she tried too soon to solve it. At that point, does that make sense?
There's always one that just really stumps us.
Yeah.
I'm tempted to even just look in the e-text to see if maybe there's like an example that might help.
Yeah.
Okay.
Oh.
So verifying that. Because I know there's like the whole identities to use. It's just like how to use them. Because there's a lot of like squaring and so 1 divided by cosecant would equal sine. Okay. Secant divided by cosecant would equal 1, right?
Secant divided by secant? I would assume
Sine
so.
divided by cosecant.
Yeah, sine divided by cosecant would equal to, yeah, just 1.
Or no, it would equal sine squared.
No, yeah, you're right, because you would have a times 1 over sine by sine, or get it to be added to 1. So you would guess sine squared as a result. Okay.
I thought I had something going, but I got stuck.
You're a better trick than I am right now. I keep staring at this, and I'm like, what happened? Ugh.
Yeah, because there's got to be some, got to be something. Well, I think she has the best, actually.
Anything different?
Well, I saw the example in the textbook, but I forgot we can't use textbooks, so we'll just have to turn in what
Oh,
what she put. So, and then after we turn it in, we can see what we did wrong. Because, man, maybe I should look at the textbook more.
yeah. I think I'll try that next. I think I'll try that next time and just kind of go through it over and over. That way, I
Yeah,
don't miss out on it.
yeah. So I'm fine with just going ahead and just submitting what Sienna has. And so then, like I said, if you want to go back later and see how it's supposed to be, it's in section 2 of chapter 6.
Okay.
So it's like towards the end of it or something like that.
All right. I'll go out section 2, chapter 6.
All right. So do you want me to turn in hers, or do you?
I think I can attach the pictures to a Word document and just submit it that way. So.
It looks like she sent them as PDFs, so you can just download
Oh,
it
right.
and just kind of submit them in the Dropbox.
Well, then I'll do that.
Okay.
All right. Well, is there anything else you need?